Hello everyone, welcome back to the series of videos on chemistry revision. Today we shall continue our topic on oxidation and reduction. In the previous video, we focused on oxidation and reduction in terms of the gain or loss of hydrogen and oxygen. Now, reduction and oxidation or redox can also be defined in terms of electrons and oxidation state. A substance is oxidized or undergoes oxidation if it loses electrons. When a substance has been reduced or undergoes reduction, it gains electrons. A substance is also said to be oxidized if there is an increase in the oxidation state of that substance, and a substance is reduced or undergoes reduction if there is a decrease in its oxidation state. For today, we shall focus on oxidation and reduction in terms of loss or gain of electrons. Okay, this simple mnemonic may help you to remember. This is a picture of an oil rig. Now remember oil rig because it will help you to remember that oxidation is a loss of electrons, whereas a reduction is a gain in electrons. So oil rig will help you to remember oxidation and reduction in terms of electrons. Now before we jump into the examples, let us take a look at two quick examples of what happens when something loses electrons or gains an electron. Look at this sodium atom. Sodium has a electronic configuration of 2, 8, 1. That means it has one valence electron. Now, to achieve the stable electronic configuration or a noble gas structure, it loses its valence electrons. Okay. So now we take a look at sodium losing its valence electron. When sodium loses its valence electrons, suddenly it has one electron less, so it acquires a positive charge here. Notice that sodium has lost one electron and therefore it has become a positive ion or a cation. So when something loses an electron, it becomes a positive ion. Now let's take a look at the chlorine atom. Chlorine has a configuration of 287. Now it only needs one more electron to acquire a noble gas structure. So when chlorine gains an electron, it becomes a chloride ion with one negative charge. So when something gains an electron, it becomes negative. So important things to remember: when something loses an electron, it becomes positive. When something gains an electron, it becomes negative. Okay, we shall now take a look at some examples of redox reactions that involve a gain or loss of electrons. Let's take a look at this first example. Sodium reacts with oxygen to form sodium oxide. So let's take a look at sodium on the left hand side here. Now this is an element of sodium, so you can say that there is no charge because it is in its elemental form. The oxygen here also has no charge because it is in the form of gas and therefore it doesn't have any charge. Now sodium oxide here is an ionic compound. Oxygen typically has a charge of 2 minus the oxide ion, and sodium here typically has a charge of positive 1. So you can see that sodium has gone from no charge to a positive charge. So we can say that sodium has lost an electron to become Na+. Therefore, since it has lost an electron, we can say that sodium has been, oxidation is a loss of electrons, you can see here. So sodium has been oxidized. Okay. Now, on the other hand, you can see that the oxygen atom here, the oxygen here does not have any charge, but after the reaction, it has a charge of 2 minus. So it has gone from no charge to a charge of 2 minus. So clearly it has gained electrons. So we can say oxygen has gained electrons to become O2 minus. So we can say that oxygen, because it has gained electron, oxygen has been reduced. Okay, to recap, since sodium lost electrons, it has been oxidized. And since oxygen has gained electrons, it has been reduced. Okay, so let's take another example of magnesium reacting with copper 2 sulfate. Looking at the equation, magnesium reacts with copper 2 sulfate to give you magnesium sulfate and copper. Now you might recognize that this is actually a displacement reaction, as magnesium is more reactive than copper, and therefore magnesium can displace copper from copper 2 sulfate. Now let's take a look at what are the charges of the metals in this particular reaction. Magnesium is in its elemental form. So clearly magnesium has no charge here, or a charge of 0. Whereas in magnesium sulfate, now you recognize that the sulfate ion has a charge of 2 minus, whereas magnesium would definitely have a charge of 2 plus. Copper 2 sulfate, on the other end, in copper 2 sulfate, you know that since the sulfate has a charge of 2 minus, the copper here must have a charge of 2 plus. And copper, after the reaction, has become in its elemental form, therefore it will have no charge. So let's take a look at what happened to magnesium. Magnesium has gone from no charge to a charge of 2 plus. So it has gone from no charge to a charge of 2 plus. Now ask yourself, did it lose or gain electrons? So in this case, clearly magnesium has lost electrons to become Mg2 plus. Thus, magnesium has been oxidized or reduced. Now remember, oil rig, oxidation is lost. So since magnesium has lost electrons, it has been oxidized. Now let's take a look at what happened to copper. We started off as copper 2 plus, and after the reaction is complete, the CO2 plus has become just elemental copper with no charge. So it has gone from 2 plus to no charge. So did it lose or gain electrons? Copper 2 plus has gained 2 electrons to become copper. Therefore, we can say that CO2 plus has been reduced. Okay, so let's do one last example and see whether we can get the hang of it. chlorine reacts with potassium bromide to give you bromine and potassium chloride. Now, do you recognize this reaction? It is actually another displacement reaction, where a more reactive halogen can displace a less reactive halogen from the solution of the less reactive halogen. So, let us now investigate what happens in this particular reaction. Chlorine here, you can see that in its elemental form will have a charge, would have no charge. Whereas in potassium chloride, we know that the chlorine will have a charge of -1, because the potassium here has a charge of K+. Okay, so the positive ion, the number of positive and negative ion charges need to be equal. Now let's take a look at potassium bromide. We know that potassium would have a charge of K+, and bromine would have a charge of Br-. But after the reaction, the bromine here is in its elemental form, so definitely bromine would have no charge. So let's take a look at what happened to chlorine. Chlorine has gone from no charge to -1. So it has gone from no charge to -1. Did it lose or gain electrons? So we can say that chlorine has gained electrons to become the chloride ion. So we can say that chlorine has been, now is it oxidized or reduced? Since it has gained electrons, oil rig reduction is gained, we can say that chlorine has been reduced. Now let's take a look at what happened to the bromide ion. The bromide ion started off with a negative charge, but at the end of the reaction, it has become bromine with no charge. So from the negative charge to no charge, or a charge of 0, did it gain or lose electrons? Now the bromide ion has lost electrons to become bromine. So since it has lost electrons, we can say that the bromide ion has been oxidized. So we remember that oxidation is loss of electrons, whereas reduction is a gain in electrons. So, in order for us to accurately determine whether something has been oxidized or reduced, we need to first of all recognize the charges of the items in the reaction. Okay, so in this particular case, you can see that we were able to determine the charges of chlorine and bromine and its ions. And in this second example, we were also able to determine the charges of magnesium and copper before and after the reaction. So, let us do a recap of this particular section. When something is oxidized, it has lost electrons. But when something has undergone reduction or been reduced, it has gained electrons. Okay, so you can always go back to the examples again and replay the video to have a better understanding of oxidation and reduction in terms of loss or gain of electrons. So I hope that this video has been useful for you. Thank you. See you in the next video.